consumption 2000 gallon per hour for 4 engines, and fuel consumption on 3 engines, that is after engine failure, is 1800. TAS when everything is good is 220. TAS when engine has failed is 3, is only 200 knots. Headwind 20 knots outbound, and reserve fuel is 1000 gallons. Distance to PNR is 600. What is fuel on board? So you have to calculate fuel on board that they have asked you. So next. So that means let's draw this route. You have A and you have B. From A to B you are going, and in between there is PNR, right? So you are going from A to PNR, PNR to back to A. Now if this is your aircraft, according to the question given, when this aircraft takes off from A, when this aircraft takes off from A and goes towards PNR or goes in the direction of PNR or Bravo, it is facing winds coming from the front. According to the question, it is facing winds coming from the front at at 20 knots. At 20 knots. So going outbound from A, there are winds coming in front from the front at 20 knots. So going outbound, you will be experiencing a headwind. And when you go to PNR, and the question states at point of no return there is an engine failure. So at PNR you decide to come back to point A. So from here you will come back to point A. Okay. And now when you during your return journey, the wind is going to remain the same which is coming from that side. Now during the return journey, the same wind will function as a tailwind. So going outbound, this winds will be headwind. Coming inbound or homebound, the same winds will become our tailwinds. Okay. Next point. Next point is fuel consumptions are different because of engine failure, and reserve fuel is given. Distance to PNR is also given to you. So let's draw a table. Now in this case, we do not need track information and wind direction information, right? Because track and wind direction when we had, we were using CX3 to find out ground speed. Now here directly we can apply headwind component and tailwind component to the true airspeed which is given to us and obtain ground speed directly. So just write TAS, write the wind component and the ground speed. Now look at this question. So ground speed outbound from A to PNR, ground speed homebound from PNR to A. When you go outbound from A to PNR, what is your track direction? That is irrelevant. Next, what is your task? Now, when going A to PNR, your engines are working fine. Engines are okay. I am writing okay. So all engines are working perfectly. So in this case, your true airspeed will be true airspeed N. That is normal true airspeed. At PNR, when there is engine fail, so that means engine's not okay, you make a decision to come back, and due to failed engine, your true airspeed will decrease. So while coming back, you will fly at a reduced TAS. You will fly at a reduced TAS. So over here, in the first row, when going from A to PNR, TAS is normal. So what is normal TAS? It is 220. So let's write down 220. What is the wind component when going outbound? The wind component is a headwind of 20 knots. So minus 20. So 220 minus 20, when you subtract 20 from true airspeed, you get a ground speed. So 200 knots. Now coming back from PNR to A, you are flying at a reduced TAS. Reduced TAS is how much? 200. And coming back, you are getting a tailwind. So plus 20. So coming back, you are going to come back at a speed of 220 knots. Now, we know about distance to PNR formula, the normal formula which is endurance into ground speed outbound into ground speed homebound divided by outbound plus homebound ground speed. This is one way. Another formula for distance to PNR is your flight fuel, that is the fuel divided by gross fuel consumption, GFC. Now, what is gross fuel consumption? It is the amount of fuel used to travel 1 nautical miles. It is the amount of fuel used to travel 1 nautical mile. So let's say you have a total distance A to B of 100 miles. Okay, out of that 100 miles, to cover every 1 mile, you require 10 kg of fuel. Okay, to cover every 1 mile, 1 kg of fuel for every per nautical mile. So for 100 nautical miles, you will need how much fuel? You will need, therefore, for 100 nautical miles, you will need 100 kg fuel. So that is your gross fuel consumption. How much fuel you need or you're consuming to travel every 1 nautical mile. So distance to PNR can also be calculated by this formula: flight fuel divided by gross fuel consumption. Flight fuel divided by gross fuel consumption. Okay. So what is flight fuel? So distance to PNR equals to flight fuel is total fuel on board minus reserve fuel. So the fuel that you are going to use for your flight, that is your flight fuel, divided by gross fuel consumption. Now in this formula, you can put distance to PNR which is given to us. We have been given reserve fuel. We want to calculate fuel on board, and we can now we will solve gross fuel consumption. Now what is gross fuel consumption formula? Gross fuel consumption is equal to your fuel consumption rate divided by ground speed. Okay. Now you are going from A to B. This is PNR. Okay. That is PNR. So you will go to PNR and you will come back from PNR. Right? You will go to PNR at a particular fuel consumption rate. So while going towards PNR, when all your engine is working fine, you will have a fuel consumption of normal rate. When coming back due to engine failure, your PNR will reduce and it will become fuel consumption R. Okay. So in order to calculate gross fuel consumption, so gross fuel consumption will be equal to uh, going to PNR. For your understanding, I am writing going towards PNR plus coming back from PNR. Because when you go to PNR and you suffer an engine failure, are you going to stay in the air? No. From there, you are going to turn back and you are going to come to land at point A. Okay, so we are going to calculate the gross fuel consumed. Okay, for every nautical mile, how much fuel is consumed when going towards PNR and how much fuel is consumed while coming back. So that, and then we are going to add both of them and then we will get a particular value. So going to PNR, our fuel consumption rate is normal divided by ground speed outbound plus coming back, our fuel consumption rate will be reduced. Okay, we will reduce fuel consumption rate because of engine failure and ground speed homebound. So fuel consumption rate for normal is how much? 2000 divided by ground speed outbound is how much? 200 plus fuel consumption rate reduced is 1800 and ground speed homebound is 220. So that will be equal to 2000 divided by 200 is 10. 1800 divided by 220 is 8.18. So on. So it keeps on recurring. So it will be equal to 18.1818. So that is your total gross fuel consumption. That is, on an average, you will need to go and come back 18 kilogram of fuel for every nautical mile. So now let's put this value in the top formula, which is a main formula. Distance to PNR equals to fuel on board minus reserve. So whenever you have these two types of fuel consumption, one for normal, other for reduced, use this way. Gross fuel consumption. You will get your answer. Divided by gross fuel consumed. So 600 equals to X fuel on board we have to calculate minus 1000 divided by 10, 18.1818. So 600 into 18.1818 equals to X minus 1000. So into 600 is 4909. 600 into 18. So answer is correction. 600 into 18.1818. So 10,909 equals to X minus 1000. So X is equal to 10,909 plus 1000. So X is equal to 11,909, which is how much? Gallons. So final answer will be in gallons. So total fuel on board is 11,909 gallons. Okay. So this is a final answer. This is how we solve this sum. So to start with, we just looked at the question, understood it, what is given to us and what is asked from us. Now that they have given distance to PNR, I know in distance to PNR formula, I have what? Endurance. So now this endurance is the key to our answer. From now, what is endurance then? Endurance is fuel on board minus reserve divided by fuel consumption. But do we have only one fuel consumption rate here? No, we have two. Okay, so that's why we won't use this formula. But we know something related to the distance to PNR formula is there. So using that we will get. So then we discussed that there is another formula for distance to PNR. Your total flight fuel, which is nothing but fuel on board minus reserve, divided by gross fuel consumed. So gross fuel consumed is how much? You go towards PNR and you come back. So the gross fuel consumed while going plus gross fuel consumed while coming back will be put in this place. Okay, and then flight fuel if it's given. If it's not given, then we will again simplify it into fuel on board minus reserve. So what we want? Fuel on board. Reserve is given to us. Substitute the values and you get the answer that your fuel on board is 11,909. Okay, so that's about it. So let's go to next question. True airspeed is 480 knots. Wind velocity is 330 at 30 knots. Track is given to you. Okay, the normal things that are always given. Distance is given total from A to B. Fuel consumption while going outbound is one thing, while coming back towards home airport is another. So that means you can see there is fuel consumed has decreased. So somewhere there is an engine failure. It's not given directly, but then we can understand this. Fuel on board is 10,000 whatever units kilogram. Reserve is given to you. What is point of safe return? Distance and time. So simple. Let's jump to the point. Always for point of safe return or point of no return, we draw the columns. So let's draw those same columns from and to, back, dash, winds, winds and grounds and ground speed. Okay. So always we go from A to PNR, PNR to B, and then come back. So ground speed outbound from A to PNR, ground speed homebound PNR to A. Now from going A to PNR, what is the track given to us? It is 200. So when coming homebound, PNR to A, our track will be 200 minus 180 reciprocal 020. Now there is only one task given to us, 480 knots. Wind velocity is how much? Is one thing, 330 at 80 knots. 30 at 80. Now let's put these things in your CX3. So first point, 200, 480. 480 is task, course 200. Wind speed and wind direction is how much? 330 at 80. Your ground speed now is 527 decimal 49. So 527 knots we will write here. Coming back 020 track speed 480. And wind speed is 330 at 80. So now 480, 020, wind speed is correct. So our ground speed is 424 decimal 6. So let's take 425 knots. This completes our table. Okay. Now here we have been given different fuel consumption rates. So we will use the other formula for distance to PNR, which is flight fuel, the fuel used only for the flight, not the entire reserve, not inclusive of reserve and all that, divided by gross fuel consumption. So which is equal to further fuel on board minus reserve divided by gross fuel consumption. Now what is gross fuel consumption? It is the sum of fuel consumption rate normal divided by ground speed outbound. Okay, so this is going outbound, and plus coming back it is same thing, but the reduced fuel consumption rate divided by ground speed homebound. So that is equal to normal fuel consumption rate is how much? 2850. So 2850 divided by ground speed outbound is 527 over here, plus reduced fuel consumption rate is 2680 divided by homebound is 425. Okay, just like the previous sum, we are doing this sum. So that will be equal to 2850 divided by 527 is 5.4 plus 2680 divided by 425 is 6.3. So gross fuel consumption is equal to 5.4 plus 6.3, which is 11.7 kilogram per nautical mile. So let's go to next page. Distance to PNR will be equal to fuel on board minus reserve divided by GFC. So what is fuel on board? 10,000 10,000 minus 2,000 divided by 11.7. So 8,000, 10,000 minus 2,000, 8,000, 11.7. So 8,000 divided by 11.7 is 684. So distance to PNR is 684 nautical mile. Okay. Now in some navigation books in RK Bali, the option A is this correct answer. But in some navigation books, the printing mistake is there. So instead of 684 option, they have given some other 800 something value. So that is incorrect. That is printing error. The correct option is this only. Okay. And time to PNR will be, in case they ask, 684 distance to PNR divided by outbound ground speed 527 is equal 684 divided by 527, 1 hour 17 minutes. 1 hour 17 minutes. Okay. So this is how you calculate. Now, as soon as you see these two fuel consumption rates given to you will use what formula? Like previously, this formula. Okay. So do the table normally. The fuel data will be given to you. Substitute that. Gross fuel consumption you have to calculate like this and just substitute the values. Let's go to the last question. Same information is given like track, task, distance, wind velocity, and fuel consumption to you. Now we have only one fuel consumption. Task is also one, so that is simple. Now find distance to CP. So distance to CP, let's calculate from 2. Now you don't even need the help of diagram if you have been consistently practicing. Automatically you will draw this table. Wind and ground speed. So ground speed outbound from A to CP, ground speed homebound outbound from CP to B, and then ground speed homebound from CP to A. So A to CP to B. So this is your diagram. Now going outbound, you have a track of 335, 335, 335. Coming homebound, reciprocal of 335 will be 155. Task is one given for everything, 195. And velocity is 260 at 35, 26035, 26035, 260 at 35. To calculate ground speed, use CX3. Track is 335. As given to you is 195. Wind speed and wind direction given to you is 260 at 35. Look at the data. 260 at 35, course 335, dash 1905. As a result, your ground speed will be 182.9, which is 183 knots. 183 knots, 183 knots. Now, coming back, only your track changes. Other things remain the same. So, track is 155. So, your ground speed will be 201. 201. Distance to CP is equal to DH O plus H. DH is 1275. Homebound speed is 201. So 201 plus 183. 1275 into 201. 56275 divided by 483. 201 plus 183 is 384. So divide the entire thing. 256275 divided by 384 is 667 nautical miles. So distance to critical point is 667 nautical miles. Now next thing they have asked us that the time that you take to reach a critical point is 55 minutes before. So you reach critical point 55 minutes before the time required to reach point of no return. So if you are, let's say for example, the time to PNR is 1 hour या फिर 60 minutes. So the time to reach critical point will be how much? 5 minutes. Okay, 55 minutes before time to PNR. So if you reach PNR at 60 minutes, after 60 minutes, 55 minutes before that you will reach critical point. So you will reach critical point at 5 minutes. What is fuel on board? Excluding reserve fuel. In other words, they are asking to find out flight fuel. Okay. So now let's calculate time to CP. Time to CP is distance to CP divided by ground speed outbound A to CP. So 667 divided by 183. So that is equal to 183. 3 hours 38 minutes. 3 hours 38 minutes. So that is your time to critical point. Now distance time to PNR is 55 minutes later. Time to PNR is 55 minutes after या फिर later, after or later than time to critical point. So time to PNR is equal to time to critical point plus 55 minutes. So 0 hour 55 minutes. Okay. So what is time to critical point? We are taking how much time? We are taking 3 hours 38 minutes. 3 hours 38 minutes plus 0 hour 55 minutes is equal to time to PNR. So time to PNR will be 3 hours 38 minutes plus 0 hour 55 minutes. 4 hours 33 minutes or 4.55. That is your time to PNR. Now time to PNR is equal to distance to PNR divided by ground speed outbound. So time to PNR is how much? 4.55. Distance to PNR is same. Sound speed outbound is how much? 183. Is how much? 183. So distance to PNR is equal to 4.55 into 183, 833, approximately 833 nautical miles. Now distance to PNR is equal to endurance into outbound into homebound divided by outbound plus homebound. So 833 equals to endurance into outbound speed is 183, homebound speed. Now this is the diagram for what? This is the diagram for data for or box. Okay, for what? Critical point. But if you do the same thing for PNR, you will find the same value. So I'm not doing it again. Okay, so homebound speed in case of PNR will be 201. 183 into 201 is 36,783 divided by 384. 833 equals to endurance into 96. Approximately 95.7 is the 95.78 is the division of this. I have taken it 96. So endurance will be 833 divided by 96, which is equal to 8 hours 40 minutes. 8 hours 40 minutes. Or you can take it to be 8.6. Okay, that is your endurance. Now let's go to next question. Let's go to next slide. Last. So we have reached up to endurance. So endurance equals to what? Flight fuel on board minus reserve divided by fuel consumption. So endurance is how much? 8.6. Fuel on board is how much? Fuel on board minus reserve is nothing but flight fuel, which is fuel. We have to find what is fuel on board excluding the reserve. Okay, and fuel consumption is 105. So we have to find this whole thing, fuel on board excluding reserve, another other in other words flight fuel, and fuel consumption is 105. So our final answer is that fuel on board minus reserve will be equal to 8.6 into 105, which is equal to approximately 911 911 gallons. 911 gallon. Okay, so very long sum, but very important for conceptual understanding. Let's begin from the start. So first, just stick to the basics. Critical point. Now critical point distance, draw the table like we always do, substitute the values. Then we came to the next part of the question, which states that critical point is reached 55 minutes before the point of no return is reached. That means if point of no return is reached in 1 hour, critical point will be reached 55 minutes before that. Means 60 minutes minus 55 minutes at 5 minutes. So same logic we have applied here. But before that we have calculated time to critical point. Okay, and then we wrote an identity which is in words, same thing we wrote what was given in the question, that time to PNR is 55 minutes after or later than time to critical point. So time to PNR is critical point time plus 55. So we got time to PNR 4.55. With time to PNR, we can calculate distance to PNR, which is distance divided by outbound ground speed. So we got distance. Now, why was it important to calculate distance? Because only in distance to PNR formula, you get an element of fuel involved, which is endurance. So then you got endurance. After getting endurance, you put the values or substituted the values in endurance formula. So which is fuel on board minus reserve divided by 105, which is consumption rate. And this is what we were told to find. So cross multiply 8.6 into 105 into 911 gallons. So select the option which contains these values. So first value is distance to CP, which is 666, 667 nautical miles. And the next part of the answer is 911 gallons. So you will select that option which contains both these values. Okay. So I hope you have understood this sum and you have understood all the three sums that we have done today. With this, I hope that you are comfortable solving all the questions from critical point and point of no return. Also, it is very important to know the theory of this chapter. So do watch the theoretical video that I have uploaded. If you have any doubts or questions, let me know in the comment box. If you have if you have liked this lecture, I hope you have liked it. So hit the like button, subscribe to this channel, and do share this video with everyone.